Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will be learning how to solve linear and quadratic systems of equations. To get started, let's quickly review what we did in the previous video. Consider the equation of the parabola x squared plus y is equal to 5. For part A, find the axis of symmetry and the vertex of the parabola. So as we learned in the previous video, if let's say you have y is equal to ax squared plus bx plus c, then we learned that the axis of symmetry, so let me write this down, axis of symmetry x is equal to negative b over 2a. So what we want to do here for part A is to rearrange this equation into standard form, as shown here. So we write y is equal to, so we can now subtract x squared on both sides. So we have negative x squared and plus 5. So wait a second, where is the b value here? Well, if you don't see it, you can actually put a placeholder such as a 0 in front of an x. So for example, we can write 0x and then plus 5. So now we have it in standard form, okay? In this particular case, we know that the a value is equal to negative 1. We know the b value is 0. And we know that the c value is equal to 5. So that means that the axis of symmetry here, x is equal to negative b over 2a, so we know b is 0, divided by 2 times negative 1. So here really doesn't matter what we divide the 0 with because the answer is still going to be 0. So it turns out that the axis of symmetry is equal to 0. Okay, so now that we have the axis of symmetry, we can now find the vertex of the parabola. We know that the vertex goes through the axis of symmetry. So if that is the x value, so let's write this in, the vertex v, we know that x is 0. All we need to do is find this y value here, okay? So how do we do that? All we need to do is substitute into the original equation. So in this case, all we need to do is write y is equal to negative 0. So we are going to square just a 0. And then we write plus 5, okay? So that means that here we have a y value is equal to 5, okay? So that means that the vertex is located at 0, 5. Okay, so we found the axis of symmetry and the vertex. So the question is, does the parabola open upwards or downwards? Well, if you look at the negation over here, that actually indicates that the parabola opens downwards, because in this case the a value, since the a value here, as you can see over here, is less than 0, the parabola opens downwards. And again, if a is greater than 0, the parabola opens upwards. Okay, so this is just a side note. Okay, so now for part B, where does the line y minus x equal to 3 intercept the parabola? So for part B, here we have y minus x equal to 3. So let's rewrite it. So we want to solve for y to change it to slope-intercept form. And now we have y equal to x plus 3. And we have the equation of, let's write it also in terms of y. So y equal to negative x squared. And then we have plus 5, okay? So now we want to know where these two equations intersect, okay? So let's graph it first. So here's the graph, okay? You can actually also do this in the calculator, and I'll show you later how to do this. But we have 2 points of intersections here, okay? We have one here and one here. So it seems like that one point of intersection is going to occur where the x value is negative 2 and the y value is 1. And the other point of intersection will occur at 1, comma 4. So it seems like that from the graph, these are the points of intersection, okay? But in today's lesson, we want to learn how do we solve systems of equations that are linear or quadratic. In this case, we have a mix between linear and quadratic, and we want to learn how to do it algebraically, right? So let's think about what has to be true at one of the points. For example, let's call this point A, and let's call this point B, okay? What must be true at point B? Well, at point B, or at point A, one of the points, right? At this particular case, point A, the y value is the same, right? They both share the same y value of 1. Both of these, right? The linear equation and the quadratic equation both share the same y value and both share the same x value. And the same thing goes here. At point B, the line and the parabola both also share the same y and the same x value, okay? So knowing that this is true, what we can do here is take these two equations, call this y1 and y2, and what we can do here, we know that in this case y1 is equal to y2, and therefore we can substitute and solve for x. So let's write this in. So we know that y1 is equal to y2. We know that both equations have the same y value. That means by substitution, we have x plus 3, and that is equal to, and the y2 value is negative x squared plus 5. Negative x squared plus 5. So now all we need to do is solve for the x value. So here we can, for example, add x squared on both sides of the equation. Then we have plus x. And we can now subtract 5 on both sides of the equation. So minus 2, and we have equal to 0, okay? Okay, so now here we want to find two numbers that add to 1 and multiply to negative 2. So in this case, the two numbers are going to be plus 2 and minus 1. Because if you do 2 minus 1, you end up with 1. And 2 times negative 1 is negative 2. Now that is equal to 0. So in this case, what has to be true is that this has to be equal to 0, or this has to be equal to 0 in order for this equation to be equal to 0. Which means that if x plus 2 is 0, that means that x could be negative 2. Or in fact, it is negative 2. Or we could have that x is equal to 1, okay? And that is basically it. So we found the x values. Now, if you go back to the graph, it makes sense because for point A, we have a negative 2 here. And for point B, we have a 1 over here. So these are the x values for which both equations have the same exact y value. So what is the y value? So what we can do is just substitute in one of the equations. For example, if you take y is equal to x plus 3, and substitute negative 2. So you have negative 2 plus 3. So here you end up with equal to 1, okay? So here the y value has to be equal to 1. And for the other one, we substitute again, y is equal to 1 plus 3. So you end up with 4. So that means that the y value here is equal to 4, okay? So there you go, we have the point. So for example, for point A, we have negative 2 comma 1. And for point B, we have 1 comma 4. And if you go back to the graph here, those are the exact points that we had shown on the graph, okay? Okay, so at this point, let's see how we can find the solutions using the calculator. Okay, so first we input the equations as x plus 3. And then for y2, we put minus x squared plus 5. All we need to do is just hit graph here. So here's the line and here's the parabola, okay? So we want to find these points of intersections here. So what we can do here, first of all, let's zoom in and see, where the points of intersections are a little bit more clear. Okay, so let's zoom in at this point. Okay, so very good. So what we can do here is now do second calc, okay? And now we go to 5 where it says intersect. So we press enter. Okay, so once we press enter, we want to select the first curve, okay? So we press enter, and now for the second curve, it automatically goes onto the second curve, okay? So you don't really need to do much, just press enter and now take a guess. You want to go close to the point of intersection, the first one, and press enter, okay? And there you go, we have -2, 1. So it's actually point A at -2, 1. Now, how do we find the other point of intersection? The same way. Second calc, go down to 5. You can just select 5. First curve. So we select the first curve. Okay. Usually it's already selected, but if you don't see the cursor, you can actually move the cursor with the calculator. So you press enter. It's asking you for the second curve. So now you jump onto the second. There you go. And then you take a guess. So you go close to the point of intersection, press enter, and there's the other point of intersection, x equal to 1 and y is equal to 4, okay? And that's the point B where both intersect. Now let's look at a different problem now that is slightly more challenging, and you might not be able to use the calculator, so you need to only use your algebraic skills, okay? So here's another problem. Solve the system of equations defined as x minus y squared equal to -4 and x minus y is equal to 2. Notice that usually systems of equations are designated with a bracket just on the left side, but it just means that you have two equations in terms of these variables, okay? So how would you proceed with this problem? So what we can do here, now we need to isolate one of the variables and substitute into the other, okay? For example, if you look at the second equation, what we can do here, take the second equation, x minus y is equal to 2. We could, for example, solve for x in terms of y. So here we have y plus 2 now. So what we can do now is substitute this x with y plus 2 in equation 1. So by doing that, so let me write an arrow like this and one like this, okay, because we're actually combining these by substituting. So we have y plus 2 and now minus y squared equal to -4, okay? So again, keep in mind that this is the same as x, okay? So let me write this in, that is equal to x. So if you think about this, now we have a quadratic equation in terms of y. So let's rearrange it a little bit. So here we have y, -y squared plus y. And let's add 4 on both sides. And now we have plus 6 is equal to 0. Let's multiply by -1. So here we have y squared minus y and minus 6 is equal to 0, okay? And now once again, we want to find two numbers such that, when you add them up, you get -1. And when you multiply them, you end up with -6. Okay, so here we can write y plus 2 and y minus 3, okay? So let's think about this. If you take 2 minus 3, you end up with -1, okay? So the first part is satisfied, and 2 times -3 is -6, so it works. So we actually end up with two different y values, y equal to -2 or y is equal to 3, okay? Now, again, we back substitute by picking one of the equations. Usually it's best to pick this one, the one you already saw for x, because it's in terms of y. So you write x equal to -2 plus 2. So that's 0. So here we get an x value of 0 for the first point of intersection. And the second point, we substitute 3, okay? 3 plus 2, and we get 5. So that means that y, or x is equal to 5 here, okay? So these are basically the points here. So the first point of intersection is going to be at 0, negative 2. And the second point of intersection is going to be at 5, 3. So you might wonder, okay, how does this even look like if we have a y squared, okay? You don't really need to know this in geometry, but just for your information, if you draw the x and y axis here, you know, we have a parabola that is actually a sideways parabola in this case for the first equation, okay? So it kind of looks like this because that's the y squared. So here we have a point of intersection at 4, okay, on the x-axis. And how do we know it? It's actually this number over here. That's the negative 4 when you solve for, you know, when you isolate x. As a matter of fact, let me write this in, that this equation is going to be, let me use a different color so it's easier to see it. So x is equal to y squared minus 4. So it's a sideways parabola. So the other one, on the other hand, that's the equation of a line. So here we did isolate for x, but we can also write y is equal to x minus 2. Okay? So that means that we have something like this. Okay? So that's the minus 2. So in this particular case, let me actually write this in. Y is equal to x minus 2. There you go. So now we have these 2 points of intersections. One is over here, okay? So that's the 0, negative 2. And I'm going to use a different color. There you go. Let me actually use this one. So we have this point of intersection here, which is at 5, 3, okay? So that's how it works. But again, you don't need to know how to graph it for this particular case. You just need to know how to solve it algebraically. So here's another problem. The last one for today. Solve the system of equations y equal to negative x squared and y equal to x squared minus 2. So again, that's very simple. All you need to do is set both equations equal to each other because the y value must be the same at their points of intersections. So here we have negative x squared is equal to x squared minus 2. So let's isolate for x. And what we can do, add 2 on both sides. So we have 2 is equal to 2x squared. So we actually end up with an x squared value to be equal to 1, okay? So that means that x, now when you take the square root on both sides, remember that it's always plus minus 1, okay? So that means now we have 2 different x values here. So one of the x values here, so let me write this here. One of the x values could be 1, or is 1, I should say, and the other x value is equal to negative 1, okay? Now, in either case, what is the y value here? So if you substitute y, then here if you substitute y into negative x squared, so you end up with negative 1 here, okay? And what about this one? If you substitute negative 1, so if you write y is equal to negative and then negative 1 squared, you also end up with negative 1. So it seems a little strange, but it turns out that the points of intersections are going to be 1, negative 1. And the other point, let's call it point A, and the point B is going to be at negative 1 and negative 1. So how's that possible? Well, here we have 2 different x values, but the same exact y value, okay? So if you would graph this, so let's say you have the x and y axis here. So one of the points is going to be intersecting at 1, and the y value is negative 1, okay? So let me write this in here. So 1, negative 1. The other one is going to be negative 1, negative 1. So it's right here, okay? So we have these 2 points of intersections. But how does these look like? So both of these are actually parabolas, okay? So keep in mind that the first one, y equal to negative x squared, is a parabola that goes downwards and has its vertex at the origin, okay? So it's just a regular parabola. But what about the other one, x squared minus 2? So here we have another parabola at 2, where it intersects at negative 2 on the y-axis, but then it opens upwards like this, okay? So, and that's the reason why the y values are now the same, okay? But different x values. But anyways, this is basically how you would solve systems of linear and quadratic equations. I hope you enjoyed this video. And, if you have any questions, please leave a comment on the YouTube video. Otherwise, please click like and click subscribe. Thank you so much for watching and have a great day.